If you're not able to figure out how to turn this thing on, you should probably change your career, right?
When I think about reality capture as an ecosystem, it is any technology that helps us collect data and create useful information out of that.
What do you do with this data? Who is the end deliverable? And as mentioned, the workflow is key. And then how do you draw insights to use this data to then be able to answer questions faster, smarter?
The future is in the software, not in the hardware probably anymore. So it will shift from hardware, from methods of data collection to methods of data processing.
And so I think adoption is the thing. Digging in and resisting is going to only kind of create problems. I think AI is here.
Ability to process and ingest and output meaningful results from data is improving out of sight.
I would also add, don't be afraid to fail, right? Because if we're not failing, we're not working.
Well, good afternoon. Thanks for joining us. We're excited to be hosting the RCN track this year for the first time. And our room is all focused on reality capture and technologies that touch the built environment. And we're kicking things off today with a very organic panel conversation around the current and the future state of reality capture. So I'll go ahead and welcome our panelists up, and then we'll start some introductions. So come on, guys, let's get started. Please give them a hand. Awesome. All right, well, we'll start with some introductions so everybody gets to know who's on stage and kind of the perspective that you're sharing from as we start our conversation. And I like to let people know when we do panels, we also run a podcast, so I like running panels kind of like a podcast. I don't tell people what we're talking about beforehand, so this is a very organic conversation. I think there's benefit that comes from that. I think when you know all the questions that are coming, you get to rehearse and research answers. I love organic conversation because I think it spars, things that you wouldn't have otherwise thought of. So if we hit any hiccups, that's my fault. I'll take the blame. But let's go ahead and start with introductions down here. Your name, title, and what you do at the company.
All right. Yes, perfect. So, hi, I'm Lisa Patterson. I'm the Director of Product at Navis. So I'm focused primarily on our software products, so Navis Ivion for 3D digitalization, our processing, as well as our mobile offerings.
I'm Khrystyna. I'm from Trimble. I'm a product manager, feature extraction. My team is responsible in integration of AI and industry workflows, automation of information extraction from data that is coming from static scanners, mobile scanners, drones. So basically, we're helping our customers to make sense out of the point cloud and image data.
Yeah, hi, Sam Griffiths from Australia, humble surveyor, integrated in project delivery. So we use reality capture for design and construct purposes.
Hello, I'm Eddie Fossler. I'm one of the technical experts at Olson. I work in our geospatial industry and formerly known as survey. So I too am a surveyor, a humble surveyor. And but I focus on reality capture and anything that translates to deliverables from that. CAD drawings, digital twin, things like that.
I'm Mike Harvey. I am with Leica Geosystems. I've been with them for 20 years. I was also a land surveyor in the city of Boston for 11 years. So, cheers to all the surveyors up here, right? What I do is I'm like I said, the senior product manager for all of reality capture. So that is everything that scans and does all the processing. The support and training teams all report up into me. And then I'm also involved with and in charge of collecting field data, customer data, and getting that into the development teams and working very closely to them to create the next generation things.
Awesome. Well, thank you all for joining this fun conversation. The first thing I'd like to do is define what is reality capture, because I think it's a term that's been growing over even just the last few years. And similar to, maybe we heard the buzzword, right? Digital twin. I think it can mean a lot of things to a lot of people. So I'll give my definition, but then I'd love to hear some feedback. To me, reality capture, historically, people thought of really like laser scanning specifically. I really feel like the last few years we've seen that start to expand to not just be the capture process, but also then what is the data, how are we using it, what's the value that comes from it. So when I think about reality capture as an ecosystem, it is any technology that helps us collect data and create useful information out of that. So how do you guys look at that term reality capture?
I'll take that because that's a great question. So as was said, that reality capture started off, I'm going to say way back, probably 21-ish, 25 years ago. And the term was always thinking of something that's on a tripod, right? And then now it has evolved into everything that is handheld, to anything that flies, to anything that is from a picture. And to me, that reality capture isn't really a product anymore. It's a process. So it's very much so like that we think of BIM, right? We have all these different things feeding into a live, living, breathing thing. And that to me is really the definition of reality capture. It's no longer one sensor. It's no longer one software. It is all about, getting and capturing real life, tangible things and creating digital twins of them.
I was going to add to that, because that's really good. What I've seen as far as reality capture too, it's a shift of mindset as well. It's a philosophy shift, because as a surveyor, what I've seen and what I've experienced, and all of us have done this, no matter the industry, is the data was collected for the single objective. Like, I need this thing, I need this question answered. And even in the early days of reality capture, as far as us getting the data, we were still treating it that way. Like, I had this beautiful scan of this wonderful downtown area, and I was only getting like little bits of curb and gutter to answer the one question that one person had. And then later on, I'm in another meeting with a whole other person, and I'm like, we have this information, we have this answer right now. Like, we don't need to go back out, we have this answer. And so being able to fundamentally shift not just my brain, but the client brain and the people who I'm working with, getting that philosophy to change into a no, don't record, don't reality capture for today, reality capture for tomorrow.
Yeah, I totally agree. That's a very great point. The versatility of data, reality capture data, that you collect data once with any sensor or with multiple sensors, and you can fuse this data, right? And you can reuse it for any other applications, because you basically capture the world around you. So today you need the data for curb, and tomorrow you will need it for something vertical, right, like a building, right, or a highway, for example.
Yeah, extending on that, I mean, there's integration's a big piece. I mean, as an industry, the geospatial industry's been great, and years ahead, I mean, we talk about 25 years ago, I still remember my favourite job being with a Cyrax 2500, sitting on a mine site, pressing a button and waiting 2 hours for a data back. We're really good at manipulating, interrogating data as professional geospatials, but the integration into digital engineering, BIM, end client use case, that's the bit that's evolved, and that's the bit that the industry's heading, and that definition of reality capture is now being taken a lot more broadly.
Yeah, absolutely. I think capture is a bit misleading, because no one's capturing just for the sake of capturing. Sure, can be fun, especially with the VLX, but at the same time, it's what do you do with this data? Who's the end deliverable? And as mentioned, like, the workflow is key. And then how do you draw insights to use this data to then be able to answer questions faster, smarter than you would be able to kind of just having to physically go somewhere every time?
Do we just drop AI now? Do we just talk about artificial intelligence?
There's so many things to cover. Love it. Thanks for all of your guys' thoughts there. What would you say today comes to mind as one of the main reasons or barriers to companies adopting it even further? I feel like we've come a long way the last few years in adoption, but what are some of the main barriers you see to adoption?
I think it still can be quite expensive in terms of just the resources you need to do it, who's skilled and able to do it. And I think this is really what the future has to hold, is how do we make it more accessible so even more people can capture data, so then we can democratize the access to this data to get it out further. But it has to become faster, easier, cheaper in order to do so.
And the software, basically, that enables the workflows. Yes, you can go outside and collect point clouds, gigabytes of point clouds, thousands of images, but if you don't have the software that enables you to actually adopt the new way of collecting data, then, well, you can look at the nice point clouds on your display of your computer, but little value. It will be easier for you to go outside and capture something with a GNSS receiver if there is no software that can help you to deal with the amount of data.
Yeah, I think, and just taking some notes from the keynote speech just before on Dallas-Fort Worth, I think one of the things that's really evolved is end user use case analysis. So people are thinking a lot more smartly about how they adopt the mass data inside reality capture and what to interrogate to get use case outputs. And there's a lot more strategy behind that. than what has been in the past. I think that's a barrier that's breaking down in industry at the moment, and it's quite strategic.
One of the things I've noticed too is what I like to call client education. And that's the big one, is I've noticed, especially on our end, the people who go out and do the stuff, who get the stuff, it's now a client may ask, and this client could be a local government, it could be a municipality, it could be just a private land developer, anybody. They have a picture in their head of what they want. And the picture is often based off of, to your point, 25 years old data. You know, it's like, I want this thing. And then you go out and get a better thing. You reality capture this thing. And you start to show them what you did and how you got it. And a lot of cases I've seen where there's a client education piece. I need to educate this person on why I did it this way, what more value we can get out of this, and then kind of holding their hand a little bit, not in a reductive way, but in an instructive way. I want to help you understand what we're doing and how we're doing this and how it brings us into a more current state of things, not just delivering old-timey deliverables.
I'm going to just add on to the education part, because to me, that if you look at the market as overall, it kind of, to me, looks like a pyramid, right? So you have at the top of the pyramid, we have the very super technical geeks that love to get into their data and just disintegrate it and just blast it to a billion pieces to get wherever they're going. The challenge is, in all of the manufacturers here that have done a pretty good job of lowering that price barrier in getting into different things. Case in point, we have sensors out there that have a single button push now, right? And I always joke with, if you're not able to figure out how to turn this thing on, you should probably change your career, right? But the thing is that they're going out and collecting all this data, and many of them don't understand geospatially what they're doing, what they're collecting, how to put it together, and any of the theory behind it of what they're really doing. So I think education is definitely a big thing. Those are not all bad problems. I think those are all going to be done. And of course, doing anything in the software, as I know we talked about software, which is a great point, to do a lot of hard things to make it easy in software, you have to do a lot of hard things in the background. So therefore, I think, I know somebody just mentioned AI. I think a lot of the things that are happening around that types of technology is getting there. So I totally see we're coming pretty close to a major barrier before it really blows the doors open.
Yeah, personally, not as a plug for us, but more like this is something we're trying to solve with RCN as a community, is bringing together all the different players, the hardware, the software, the users, because to the point of education, I think that is one of the biggest keys to growing the industry in whole. It's a mix of education from what's been mentioned, right? The client side, the project use cases, but then also on the user side, there's not really a lot of people creating experts in these technologies, right? I'd actually love to hit on that point and hear some feedback, because I think there's a lack of skilled professionals who really know how to do this well. And as we're seeing this demand for all these technologies grow, 10 years ago, I like to say there was nobody asking you to come scan a job. Like, it was you adopted it for your company and you were like trying to convince people. Today, that is starting to change, where any hospital project, any airport, they all are demanding it. And as we see that, there's a lack of companies that have really enough resources, I think, to deliver what will be demanded in the coming years. So how do we solve some of the problems there?
Yeah, I'll take that. That's spot on. As we've seen, data capture, reality capture commoditized. The back-end software, advance in its capabilities, our interoperability between systems and end users. What comes out fundamentally, and that's really applicable to this audience here, is the quality assurance processes and the smarts behind verification of your data, and to understand its fitness for purpose. And that's a real big one in the space I play in the project's delivery. The opportunity for the surveyor, for the geospatial professional, is really migrated into that quality assurance process, as opposed to raw data collection or data manipulation. That's what you put your name to. There's a verification process. That's what you pay for. You pay for quality and assurance. So I think that's a big opportunity for the profession to move forward and to take some measures of accountability for, and take ownership for.
I think as far as education, I think the interesting thing, especially with the training team that is part of my team, I have older kids now, but having them grow up, especially through the high school age, They were always interested in say, Dad, what are you doing? What are you doing? Let me see what you're doing. And then I would actually watch their interaction of how they saw what Dad did. And a lot of times they were like, oh, well, that's cool, I think. Well, okay, was it? But, oh, wait about that. Of really interesting of trying to change the way that we educate our younger people, right? Because the younger people they're not the tomorrow, they're the today. So if we're missing the boat on this educational group of people, I think we've missed the boat, because then it's going to be much more challenging, and there's going to be less and less and less of this. Look in case point, some of the surveying profession is, there's the ratio is like for every 6 people retiring, there's 1 new one. So that becomes a challenge of how do you do that? How do you create a continuing education of these things, of getting point clouds out there? So, I mean, probably all of us could probably say, well, if you like video games, you can do laser scanning. Well, that's very true because you're spatially aware. But the challenge is understanding what you're doing with it.
A question for the panel members here is it's not understanding the United States market, but do we have processes of regulation, ISO, behind the way that we integrate reality capture or survey? What's the standardizations?
One of the things I can attest to is Alta NSPS 2 versions ago, surveyors out there, correct me if I'm wrong, finally added into their table A items reality capture qualifications. Item, I think it's 15 at the very bottom, or one of those at the bottom. So that was a new thing, and you get to see that in there, like actual, like a verification of the accuracy and quality of a reality capture scan. Beyond that, I think fairly recently there's been all sorts of qualifications and clarifications on accuracy standards for that. Again, I think a lot of places it's a mixed bag. Some states are better than others, and I think on a national level there are some qualifications, mostly in the LiDAR spaces, I think, honestly. The terrestrial stuff I think is fascinating to me because largely, like a lot of, not just survey, but reality capture or surveying instruments, I think the initial take from the industry and at whole, you could probably speak to this too, was, oh, it's another surveying piece of equipment, cool. You know what I mean? It really wasn't looked at for what it really was. And now it's just being used, to your point, beyond what its initial thought was. It's like you're doing a scan of a corridor, now I'm pulling out vertical parts of this, not just horizontal parts of this. But there are. I think it's a lot of that is catching up to the technology. The technology was way ahead of of our ability to start to kind of qualify and clarify those things.
I've got a question actually for the room, just by a raise of hands. Who's in their first couple years of wanting to adopt different reality capture technologies? Like who's earlier in their journey here? No embarrassment here. This is just, there's a good number. There's a good number spread around. And that's where I like to talk about, some of us that have been in this for 10, 15 years, we feel like, oh, everybody's doing this. There's people today just getting started. And that's why I think having these conversations is so useful and important, and building community around this is sharing these learnings, right? Nobody starting today should have to go through all the same headaches we've gone through the last 10 years. And I think by sharing these, we can help solve some of those problems. So for those that are still newer in their journey, how would you guys recommend companies getting started in, where do we start? And I even think that's more difficult today than it was 10 years ago. 10 years ago, there was like 2 options. Now there's 50, and there's handheld, and there's phones, and there's mobile, and there's, how does a company get started with reality capture and growing their program?
That's a really good question. I think we've kind of touched upon it a little bit up here of all of us is, first, when you're getting into reality capture, typically you have a project in mind, and then you're going to be buying a sensor that's fit for purpose. And that's okay, and there's nothing wrong with that. And that also goes back to one of the original questions of that many people think they're buying this thing and their thinking is very linear. So, okay, I'm going to use it, and I'm going to use it for this thing only. Well, as he said that there's, when you get a point cloud, it's going to be used for so much more than just that thing, right? It's a very much outside the box thinking. So once you've gotten yourself into it, I think that find a software path that you like, because most of the softwares today are becoming very open and coming that they're able to bring in whoever sensor, doesn't matter whether it's ours or somebody else's, doesn't matter, because I think the industry is starting to understand that the addressed market is very small compared to what's really out there. So therefore, I think we're really starting to accept more of these general formats so that we can get into these workflows. So my suggestion would be find a workflow that you like, and then master it, and then it doesn't matter which sensor, and you can always build from there, and then start to branch off. So become a master at first thing, and then continue your education.
My add-on to that also would be decide what it is, the kind of work that you're going to do. I think to your point, you can use reality capture, and I hate to say this, but for nearly anything. That's almost too much. So I would say pick a thing that you want to do, a topo survey, an ALTA survey, something like that, and then use this for that purpose. In using it for that, you will automatically begin to see other case uses for this data. Yeah, the unit type, the software type, to your point, Matthew, this is a way bigger field than it was 10, 15, 20 years ago where there was maybe 2 or 3 options. Now there's a ton. And so the big one is pick the project for sure, but then within that, start to see the opportunity for other things. I'll give a quick 30-second example. We bought a scanner. It was a Leica P20. We had the one project in mind. It was a big power. It was like substations. We were going to scan substations. And we scanned all the substations in Omaha, not all of them, but a lot of them. And we had all this data, and we showed it to the client, and they were like, well, what do I do with that? And we're like, I don't know. It's tied down to coordinates, so we're good. We know it's all good data. And then I began to draw. I drew cross sections. I extracted meaningful data from it and got it delivered to them in a meaningful way, and it changed the dialogue. Now they knew what they could see, and then I'm like, well, what else do we want to do? So we started pulling out structural pieces, and it pulled in the structural engineers, and it pulled in other disciplines. And so before we knew it, we had surveyors being involved in discussions and meetings that they never would have been involved with otherwise, all from a data set that we scanned, and we really had no idea what we were even doing initially. So that's a quick little example there.
I would also add, don't be afraid to fail, right? Because if we're not failing, we're not working, right? Because that's some of your greatest lessons is through failure. I mean, I remember the first time getting involved with laser scanning. That was at the turn of the 2400 and the 2500. And yeah, I lost my shirt on a couple of jobs. It was ugly, but I tell you what, those are some of the best lessons ever that will start to fine-tune you because you have to do it very quickly. So don't be afraid to fail because that's important.
Those were like diesel-powered scanners, weren't they? They were.
Yeah, the cables were big as this microphone.
You had to wear goggles when you turned it on.
Love that point about failure. I like talking about that a lot. It's like an entrepreneur and encouraging people to try new things. Is like if you're afraid of failing, you're never going to do something new. But the one thing I would say when you talk about these technologies too, right, is a lot of us work in industries where failing could be critical. So the other part I would add on to that is a lot of companies, if you're smaller, sometimes you don't have the luxury of like an R&D department who's going to try all this for you, and sometimes you want to go out and risk it on the project. What I would encourage is, whether you're small or you're large, is you have some time to test those and vet those the best you can before you're on a real job, so you save yourself some of the headache that could come, which sometimes is inevitable. You still run into those situations, but fail on the test jobs as much as possible.
Many of the manufacturers also have, in part of their training routines, that for that first job, and if it's really mission critical, pay for the trainer to come out and help you with that job. Have that expert that has those gazillion years of experience say, let me handhold you for this one, and then we can come talk about it later on.
That's a good point, and I would take advantage of that, being not on the supplier side, but we've certainly had relationships with our various suppliers over the years, going back all the way to those old Cyraxes, where we've worked with our manufacturing partners to learn workflows, to integrate into delivery. And I guess it comes back to that strategy piece again, is trying to identify something tangible that you understand in terms of a deliverable, being able to master that, and then trying to interrogate what you can do next. I think there's a lot of toys out there, but if you go with what you know and what your clients are used to start with, you'll get a lot of support in achieving those goals.
I really like this point about testing the equipment for the purpose that you want to use it for in the software. Because we as vendors, when you're testing this, we like to hear your feedback, and it helps us to understand what is actually going on in the industry. So that's basically the only opportunity for us as a software and hardware vendor to refine the workflow so that it works for you for your real project.
Love that. We are going to keep conversing, but I do want to let you guys know we will take some questions. We'd love this to be interactive with you that are here, that have questions, that are learning. We've got a diverse group. We didn't plan this ahead of time, but we might steal one of these mics, and maybe DJ or Phil, I could get one of you guys to run around with the mic for questions. So throughout the rest of the time here over these next 30 minutes, just raise a hand if you have questions, and we'll intermix you guys as we keep the conversation going. I'd love to talk about standards and industry-wide best practices. There are so many people that have questions, whether they've already adopted tools or they're looking into tools. What resources are available, or is it kind of a per company? And do you see the need for some type of standardization, right? Interoperability between softwares, or breaking between ecosystems. We hear a lot of conversation around those topics. Would love to hear some thought.
Yeah, that's a big one. Certainly from a digital engineering perspective, I think that the integration of reality capture into those digital engineering, that's governed quite heavily by standards. They're not so much on the survey side of things. They're more heavy on the DE side. Likewise with BIM and architectural outputs, there's quite heavy, alignment to existing standards there. So there is existing standards that often sit end user side, less so on the reality capture survey side. It's kind of a bugbear of mine. I think we, as an industry, should probably govern ourselves a little tighter in terms of how we take ownership of our own data, because I think that's a big one about how we drive our own quality and future-proofing as part of what we do best.
Yeah, to your point, exactly. Like a lot of firms, ours at Olson right now, there is company-wide, but that's not profession-wide. And largely, my reference to the Alta NSPS is that's the closest thing I think we've seen to reality capture standards. They didn't really draw any distinction in that between aerial capture and terrestrial capture. There wasn't a whole lot. It was kind of lumped into one big group. And to your point, what happens is you have this 3D captured model that's getting handed off, and then what's then held to the standard is the product from that raw data, from that data.
How do you express the standard in your deliverables?
So we have some language codified, basically giving a certain level of accuracy that we'll certify to, and we kind of verbalize that the same we would have for any sort of horizontal, any sort of structural type of surveying that we would have done. We would certify within, say, 1/4 of an inch or whatever that is. And then we also cite the actual instrument we're using and their specifications as well. So we kind of include that in the verbiage so that they know this is the instrument we're using, this is what it's able to do, this is what we're going to certify to, and then we then kind of hold ourselves to that. But that's kind of on the company side. I'd love to see it on a larger thing. Yeah.
Yeah, maybe going to the other piece of the question around like data interoperability. I think that's a really interesting topic, especially as you see more and more data now in the cloud. So you have the opportunity to really be sharing data. The tricky thing is for a lot of companies, their secret sauce is their proprietary format. Mm-hmm. So how do you balance the value that you can get out of having your own formats with also then being able to generate more insights by sharing data across platforms, because not every software vendor is going to be the best at everything. So to maximize the use of the data, you need to be able to share with these different softwares. And I don't think the industry yet has figured out the best format for doing that. And I'm looking forward to see kind of how that changes in the next years.
Yeah, that's an excellent point, actually. Of course, everybody's dream is to have one ecosystem, right? One software, one hardware, standardized for all types of data collection, all types of extraction, analysis. Ecosystem is great, and maybe primary software that you're using, primary hardware that you're using is great, but your ecosystem needs to be interoperable because it's very unlikely that there will be just one single software for all types of applications and all types of integrations that you'll need.
I think with standards that there's quite a few different standards out there, and I think it has a lot to do with whatever the project you're working on. Obviously that there is concrete standards in the ASCI standards for concrete. There is the ASTM E1155 standard for floor flatness. Of course, there's the ALTA standards that was talked about. There's all sorts of different standards that are out there, and to me, it's really one of those things of that standard of the survey or whatever you're collecting is understanding what your instrument is going to be able to achieve, right? Because as we even all of I'm going to say most of the manufacturers, I'm going to pick on myself for a minute, but when you're modeling anything, typically you're going to have, if you turn a point cloud sideways on a wall, there's a little bit of a thickness to it, right? So you have some range noise in there. Typically, most modeling programs you're going to take the mean. It's going to right through the middle. So, okay, so now what does that mean? So does that meet my standard that I have? And then even with some of the BIM standards, if you go to your LOD 200, 300, 400, 500, what do all those things mean? Is that sensor that you're going to have will be able to achieve that accuracy that I need to do? And that's one of those things that I have an interesting conversation with a lot of people that we have some of our aerospace or anything like that. It's like, okay, well, I need to scan something and I need to be like less than a millimeter. I'm like, okay, you're talking to the wrong department, right? Because that's metrology. Our laser scanning is not going to get you there. But if you're going to map it, and I can tell you where every bolt is, to the nearest quarter inch, eighth of an inch, or whatever, we're talking. So I think it's really understanding what the standard of the survey is, and then understanding your device.
And also, if we're talking about the industry standards, right? For example, ASTM standards. I don't think that all those standards are adapted for the new technology that is available right now for scanning. For example, my team is very much involved right now in transportation infrastructure and payment inspection. And I would say it's very hard to adopt ACM for payment inspection to the ways of data collection and the new ways of assessment to this old standard, because that standard was meant to be used for visual traditional inspection. This is the work that vendors and industry leaders have to do together still.
I totally agree. And it's also a change of the guard, right? It's out with the old, in with the new, right? That, a lot of these concepts are the same, but of getting those people to agree to these new ways. And I love the point of visual, right? Because most of our sensors will have cameras on them. It's like, well, that's visual, right? Well, no, that doesn't mean that I'm actually physically looking at it. So.
Love all those points. What about the data problems that people have? So, someone's transitioning from old workflows and CAD to now trying to jump into this world and getting scan data and drone data. And of course, no IT department is happy anymore. We're causing all kinds of problems. How are people to approach the data that starts, coming out of this?
Where's my friend there that has the T-shirt that says "massing effing data"? Yeah, there it is, right there.
Yeah, there it is.
That's true. That's right there.
That's true.
I would say that file sizes are definitely a thing, right? Because sensors are becoming faster. They are becoming more inclusive of very high-end imagery. Right? All those things take up space. So there's all of us, I would say, myself included with Hexagon, we're looking at a lot of cloud-based storage, right? Because cloud storage is cheap. But I know for a fact I have volumes of hard drives sitting at home of just stuff, and then moving it forward. So it's always a challenge to keep your data up to date, for sure.
That and getting back to education. So the data is big, and the storage is honestly kind of not to say the easiest, but it's the most obvious problem. It's like, this is big data. What do I do with it? Where do I put it? The funny joke was we had one of our giant models I had scanned, and it was probably approaching a terabyte of data. And pre-pandemic, right before the pandemic, I'm like, I got to put this somewhere. I put it up on our file server, and I got an email from our IT director, and he's like, what are you doing? Like, you are saving so much data. And but the thing that I noticed the most also is, again, back to getting workflows. This is big data. How do I work with this big data? How do I section it out? How can I show people how to work with this in a way that still it might take a little bit more time on your end, but what you get out of it is that much more meaningful, and just teaching people how to use this big data. Quick easy code, work off your local hard drive. Quit trying to quit trying to do this. But that's another part of it too, is just getting people to learn how to work with this big, quote unquote, big data.
Yeah, because if you have big data, right, it loses value if you cannot extract information that you need from this data.
Yeah, you show people this
in
giant model.
automated way, right?
It's like trying to eat Thanksgiving turkey all at once. Like you got to cut it up. You got to cut it up into pieces, section this data out. Classification is massive in this and things like that. But yeah, you got to be able to parse out your workflow.
Okay, I'm going to pause for a minute because I know we keep talking and we could talk about this stuff all day, I'm sure. But let's see if we do have any raise a hand for questions. Somebody has to break this ice. Okay, Phil, could we have you run mic for us?
We'll steal middle here, you guys, and then you guys can share mic. So thank you. You're right.
First, Phil, right here, first question. Thank you.
The future of reality capture and AI.
That was a statement, but we'll turn it. No, I'm just kidding.
That
We'll turn it into a question.
I think you answered your own question. Look, and this comes back to a data point of view as well. I mean, our ability, I'll go back to my earlier statement, as surveyors and geospatial professionals, we've been well ahead of the curve in understanding how to use and interrogate spatial data of high density. Our end users, less so. But with the advent of machine learning and the ingestion of point cloud imagery and other reality capture sensors, we're able to interrogate that data to give insights that relate back to use cases. So, and this will be a great one to throw to Lisa, because she's all over it. But our ability to extract meaningful information from data sets and apply that and adopt it to tangible outcomes is what it's all about. And that barrier is being broken down right now with machine learning and AI. It's in play already. Lisa?
I completely agree. I think if you look at AI across any industry, it's all about just doing things by systematic way that you then don't have to think about yourself. I think the most important thing is obviously you need to have the right input systems. And I think this is something we'll see a lot of now, is going from, basic classification, doors and windows, to actually something that could also be very specific, for example, in automotive manufacturing, and really being able to know what is this exact piece of machinery in there, how many do I have them across the globe, and then how do I use that information to be even faster. And I think this is really something that is hard to quantify, because as cloud computing gets faster, just the ability for deep learning is easier and easier with time here.
Yeah, and the future is
Oh, you go ahead.
The future is in the software, not in the hardware probably anymore. So it will shift from hardware, from methods of data collection to methods of data processing, to the point of everyone here, and to the point of very specific targeted workflows. I think this is the future. Nobody's anymore impressed, my software can classify the data into trees on the ground, or we can extract the center of the pole, or we can extract the outlines of the building. It's not anymore innovation, it's a necessity. So the future is in targeted workflows, and the future is actually in industry adopting these workflows and validating this workflow, so they can say, okay, for example, I'm a certain DOT, right? I validate that this workflow works for, certain asset inventory, right? So it's a standard, so all the other DOTs can use it.
To Khrystyna's point, there's software now that has base AI in it already in the tool sets that already utilize this. Cyclone 3DR, for example. There are software packages now that have base recognition of objects in them. This is today. This isn't even the future. And so the conversations, automatic line extraction, and that's become something as well. And there are tools for that. They're not great. I mean, they're still they got kinks in them. And there's people that got to go through and iron out these, these kinks and these line work on this line extraction. But at the speed of which this is going, we're already kind of in a group discussion at Olson, working with software tools to see if we can't even come up with some custom tools on how to extract line work off of specifically hardscape scans. But it's a matter of time at this point. But to your point, it's all software driven.
I think to the point of AI, it's, and I said this in my earlier session, that AI to me is, I think, one of the most exciting parts of working with a lot of the R&D teams. And we've all hit it right on the nail on the head of processing things quicker and more efficiently. But AI is going to go way further than just the data. Right? AI is going to allow sensors to think a lot faster and provide answers to complex problems quicker. And AI is not just the point cloud either. AI is going to be applied to imagery, right? So all of our sensors create massive files of imagery. So in many countries, when you are scanning, you need to have something in there that is going to very intelligently clean off facial, any faces, license plates, those types of things. So there is a lot of different things that AI is going to be used for, especially with a lot of my interaction with the R&D teams with Hexagon. So, like I said, just think way bigger than just point cloud. The idea for the end customer is to get your answers to complex problems quicker, probably in the field. So a lot of the things that are traditionally done in the office will start to move into the field when we're seeing that clear across the board. I know my friends at Trimble are doing it. I know, Navis is doing it. We're doing it. Everybody's doing it. So that is definitely the natural progression of that. But I think just think of AI much bigger than just the data. It is also all the back-end components of the things that are happening in there that is going to allow those things to go a lot quicker.
I'll just add the one point that just came to me then. As surveyors, geospatial professionals, we tend to think a little statically. One of the things that, we go back to the keynote presentation just earlier in Dallas-Fort Worth, is the application of real time. The ability to process and ingest and output meaningful results from data is improving out of sight. And we're now talking about real-time sensors. And I'll use a pragmatic example of that. Say, we do work in rail operations and maintenance where we use LiDAR sensors through the rail corridor to interrogate for track inspection purposes. We're looking for anyone can look for defects. Defects are easy. They're algorithm-based. You can tell if your track geometry's off. You can tell if there are infringements there. But your ability to change detect in real time, and look at predictive maintenance outcomes, that's the future. That's where things are going. Not quite there yet, but that's where things are evolving quite rapidly.
And also customization of AI, quick customization. Because, there probably will be lots of workflows very soon available for certain industries, right? But there always will be a very specific unique need for every project. So the tools, AI tools that will be quickly and easily customizable, that will be the future.
And I think something to keep in mind is that in order for these technologies to continue to get better, they need to have models being updated on more and more data. So we also are responsible for feeding data through these systems so that then we can continue to see improvements in the algorithms, in the models that we have. So it's self-fulfilling in that sense too. We get value and we're making a better product long-term by adding our data in it so we can continue to learn.
And coming back to the importance of the people in the room, as we move into more AI-dominated landscapes and real-time applications, the measurement science is still fundamental. So our ability as a profession to govern those outputs is going to be very integral to the process. And so that's really, a critical point to make in terms of how we fit into this picture.
See how far you can set us on one question? We could just keep talking in circle now. Let's get another hand. I see another hand over here. If you don't mind, Phil, running over there. 3 rows back. Thank you.
Sorry, we're going to stay on this topic. So what do you think is the biggest impediment to the acceleration of AI in this space? Is it formatting, data formatting problems? Is it standards to the standards question? Is it, Lisa, you said, the classification of very, very detailed things, like a software engineer can build that, but still has to have a standard to work off of, or a giant translation system of all the different coordinate systems, all the different standards out there. So what do you think is the biggest challenge that a AI-enabled software that would be operated in this space would need to overcome?
To me, it's data flow between systems and speed of delivery and absorbing the data. We can have mega computers now up in the cloud to do all sorts of different computing. But we all know that 5G was promised to be this saving thing, and it's not. So therefore, I think with a lot of the data formats that we have out there, so format is probably one topic. I think it's data size and being able to feed something that quickly into those types of algorithms, right? So would you take an RTC scanner, for example, which is large, and then you're going to feed that into another system through the cloud to do something or transfer it over, there's a pause. So I think for those AI systems to be working, I think that there needs to be much better transfer of data quicker, because I think a lot of the systems are able to do it now. The challenge is just speed of getting the data into those systems.
I think another component of that too is adoption. I think that my opinion of this, and I've been doing surveying for 30 years, 15 of which have been scanning or reality capture. And what I've seen, at least in my experience, is a somewhat what I would call a reluctance in some cases of speaking directly to survey, a reluctance to embrace technology that could maybe compromise jobs. I'm afraid, I'm a CAD guy. My background is in CAD, and when Land Development Desktop came out, it was like, oh my gosh, it's good. They combined Sofdesk with CAD. And then Civil 3D came out, and it was like, oh my gosh, we don't need redline drafters anymore because it's all annotative and it updates itself. And so I think adoption is the thing. Digging in and resisting is going to only kind of create problems. I think AI is here, it's happening. I think fighting it is not necessarily the smartest thing ever. I think leaning in is the thing. And I think that's kind of my big gut check. Is when GIS came out, that was a big, the joke get it surveyed. When GIS came out, there was kind of, I think, an industry resistance to adopting that under the survey part. And so I think my experience has been just looking at this and going, this is where we're going, this is what's happening, we need to embrace this and run with it. The more people that are helping, the quicker and more, efficient this can go,
Yeah, and I think adoption of any sort of technology, AI or otherwise, it needs to fulfill a purpose. So like our product team, we focus on jobs to be done. What is actually the job this data needs to provide? What am I trying to do? And I think the power of reality capture is there's so many applications of this data, and there's that combined with so many applications of AI means there's not a lot of focus yet. And what are the actual jobs we're solving? And I think this is something that needs to be ironed out to have it be even faster for having people to adopt it, because we know we can concretely see the benefits of how it improves the workflows, the deliverables, and the user experience of the data.
If you guys want to, while we keep answering, I know, if you want to raise hand again, we'll kind of keep a couple questions in queue so we can run around. So, yeah, go ahead.
This will require probably higher level of domain expertise, because there is no need, or there will be no need anymore to do very simple repetitive tasks, right? But there will have to be a domain expert that has very, very good knowledge of what is being done for a certain project that will be able to supervise the automatically generated output. That's what a colleague said. Sorry, Sam. Oh my God, we spoke like for 5 minutes.
Mr. Thomas.
So the capabilities of large language models are possible because of the accessibility of an internet scale data set of text, an internet scale data set of images. What needs to be true in order for there to be an internet scale data set for reality capture?
You stumped us. Next.
That was a good
I'm
one.
just kidding.
That was a good question.
Well, I mean, nobody's answering yet.
Is it more so about cloud computing and less so about internet connectivity, or are you talking about?
I think you're saying a repository of a lot of data to be trained off of.
Exactly.
So maybe
right now, if I wanted to create my own large language model, I would just go out and scrape the entire internet.
Yep.
But if I wanted to create a kind of a foundation model for reality capture, classification, generation, et cetera, there's no internet that I can go out and scrape. I'd have to go to all the big players, beg them for access to their data, which would probably get a lot of doors slammed in my face.
Yeah, there are open source machine learning models at the moment for point cloud classification. It's been the origins are from self-driving automated vehicles. They are available to help train and classify your data sets. You can take that a lot of different places. But I think we'll see those open source models be more accessible moving forward. If we're talking specific, and imagery is obviously, there's a huge training base for that's used. It's a lot simpler because it's a 2D oriented perspective, so you can interrogate and train very, very quickly. Point cloud, less so, and there's a lot of data science behind it. It's way above my level of understanding, but for the work that we do, we do access existing open source models at the moment, and and use your own machine learning basis to produce the outputs, and then there's a huge compliance check verification process that we do internally. But I can see it improving. And I can see it being more available regularly to bodies outside of, just standard works. But as best as my answer goes, it's largely originated from the autonomous vehicles.
That's a very great point, actually. I think what will happen very soon is that there will be tons of model architectures available on the web, right? But the one who will have the data will have the power. If, let's say, you want to train a model that will detect a specific type of, a window or specific type of a pole of a tree, right? Okay, you can find the model architectures on the internet pretty easily, but you have to train on something. So yeah, as you said, either you'll have to beg somebody for the data, and I think as this knowledge about how AI works and who actually has the power, not those who can train the models, but those who have the data to train the models. There will be probably some challenges when it comes to sharing the data, because everybody knows what the data is shared for. Another interesting topic right now is synthetic data. So synthetic data will become more popular. The problem right now with the synthetic data that it's not yet realistic enough sometimes that it can be used for training and then applying this model for actual recognition of actual objects. But I think we're going there.
One thing I'll throw in, and I'll plug again, Thomas is on our committee's advisory board, and we have one of our co-chairs of our scanning committee. Those that don't know, this is one of the reasons we've created this committee's organization, is saying we see a lot of problems in the industry that we don't see industry solving. So we as a community have the power to bring the professionals together and start identifying our own problems and share data with each other, create guidelines together, create standards together for things that are missing in the industry. So that's one thing that we're trying to solve as a community is let's work together to identify the problems. And then, we have meetings on a bi-weekly basis with professionals around the world that are working together to collaborate on these problems. So I think a lot of these issues that exist can be solved by us as a community, both from the support of the manufacturers as well as the users and end owners. Next question.
Yeah, I'm new to reality capturing, but I saw some demos, and most of reality capturing are about reality. That's large scale, close to human scale. So I don't know if the georeference matters in that process. So if it does, it has to be using certain kind of reference system. Wonder when you do reality capturing initially, what consideration in terms of coordinate system used? Industry standard, does it really matter? Is there a neutral? I guess so.
Yeah, great question. We have a bunch of surveyors. We can answer that. No.
My professional, my colleagues are clapping their hands. We talk about this a lot. I will say this, georeferencing always matters. Even when clients say it doesn't, it comes back and it does. Because they're like, well, I don't really care. I want this right here. I want this scan. I don't care where it's at in the world. And then at some point, someone is like, well, I needed to know where that was relative to the street, And so after 15 years of doing this, I have seen georeferencing always comes up. And it comes up usually after we've done it, and it wasn't georeferenced. And they're like, but why isn't it relative to anything? Because you said it didn't matter. So we've learned kind of the hard way. We georeference 100% of what we scan. That being said, a lot of times it's driven driven by the project. Whether it's like a Department of Transportation, then they have a system they'll want that tied down to. Usually, depending on the state we're in, it could be state plane, it could be a modified state plane, it could be something like that. The part of the country we're from, recently they've redone a lot of the coordinate networks, and so we have a low distortion projection for these areas. So the long and short of it is it's kind of client driven in some cases on how the coordinate system is going to be. A lot of cases it's surveyor or the geospatial professional's preference on what it needs to be, or the local municipality. But the point is, I believe strongly that georeferencing your reality capture is probably the best practice, to be honest, in my opinion.
I would say, I think as the demand grows, I think geospatial becomes more important. You know, organizations who have buildings or facilities all over, they want to know where they're located. It's within a project. But I also think that it's important to approach everything as a per project basis. You know, so like you said, if someone was literally trying to measure this stage and that's all they cared about, then it's too much work to bring a surveyor. I come from a survey background. I support survey, but I think we have to look at every project, every client, every use case, and then work our way backwards from what tools should be used and then what projects, you know, require or don't require. And I think there's also two things which we didn't dig into this, and we're probably running out of time to go too deep on it, but I want to at least still mention it on the survey aspect. Is there's two things that come into play with survey on these projects with scanners too. There's the georeferencing of the data in whole in the coordinate system, but there's also the control piece that helps with your accuracy of your data. And whether you're using a SLAM device or a terrestrial device, I think that's one thing that is not talked about enough in the industry is, you know, a lot of people run out there and just buy a scanner and they think that whatever the stated accuracy of that scanner is what their data will be when they're done scanning a site or a building. And that is not the case. You will get all kinds of error built up in your data from SLAM, from drift, from overlap of scans if you don't have enough overlap. There's a lot of things to consider. And so I always encourage people, at least ask your vendors about that if you're considering a piece of hardware, or find someone who is a user that's a third party and like ask about those questions of when survey becomes important prior to kind of picking your device or running out there and using it. We do have time for maybe one, maybe two more questions. Okay, we got all the way in the back corner, Phil. Thank you. While he's getting him the mic, I'm sure there's more questions. So everybody, including myself, we'd love to continue these conversations post-panel.
So at what point, or like, what's the time frame when Skynet is going to go live? Or, you know, like, I have a really pointed question. So I see AI doing all of we're already doing meshing, right? So at what point can I have a mesh from my laser scan recognize a specific piece of equipment in a plant and then pull up that 3D model and pop it into my building? Like, where do you see that at? Is that 2029? What years?
Yeah, it's a good question, right? That's the holy grail, right? You scan something and out pops a plan. I'm sure probably every manufacturer sitting up here is going towards that, and that is the holy grail. The challenge is with anything machine learning and those things, two things need to come into mind. First, common sense. We're going to use common sense with this, right? Because the way that machines learn can be rather scary. We've read news articles that these machines are talking to themselves in a language that none of us have come up with. So that's kind of interesting. So we have to keep that in mind. Also, as we're teaching these models to do these different things, that a pump here in the United States may not be the same pump anywhere else in the world. So therefore, we probably have hundreds of thousands of different things from around the world that we need to capture models of and start to teach a point cloud to do those types of things. So when it's going to come, I can guarantee you that all of us are trying to get there to help with that type of thing. The challenge is, and I think it kind of goes to his point of what's the really barrier of this thing, and it's all about data sharing. Is everybody willing to share your revenue source so that these things can be built? And that's a really philosophical question of where you want to take that business.
Yeah, I think there's a bit of, we're kind of doing it now about it. And there's the second part is we're kind of not doing it as well as we can. So certainly it comes back to that fundamental question here is how do we keep training and machine learning to auto classify and get the results we want? We can do some things really, really well. So in a linear sense, a pragmatic example, we can pull rail strings off a huge network and, just using machine learning processes, overheads, structural information, but it's an internal process of training and machine learning to pick out those features from those trained data sets and run in a verification process to determine the success. And in practical senses, we're doing that already to better than what a manual extraction process would look like. It's just not for everything. It'll come.
I'm excited for when it gets there, though. I want to open up my reality capture software and just ask it questions and have a conversation with it like ChatGPT, not have to manually slice and look for the walls, but just be able to converse with your data of like, how many doors do I have? And then it tells you, and then just like you do with ChatGPT, right? Then ask the next question, like what material was it? What are the sizes? How many, I think we will get to that point that our software, I think that is the biggest area for improvement, right? There's so many devices, we can capture so much data, but what the software can do with that data is going to be quite impressive. And I will say we are out of time. We have panels and presentations going in this room all week, and I'm sure everyone who's involved would love to continue conversations with you guys. So thanks for joining us for our first panel, and give it up for our panelists today.